Thank you everyone for joining us today. We've got Chris Walker from IBM, and his session is managing and optimizing workloads in a consumption-based world. Looking forward to this session. Chris has said that he's quite happy to take questions during the session. So if you have any questions, please send them on the chat and I will put them to Chris if he's unable to see the notification whilst he's talking, or we can put them and save them to the end. There is a slide that will pop up about the charity raffle if you're interested in entering that raffle. Chris, yeah, thank you, Chris. So yeah, this is the slide about the charity raffle. If you're interested in being and entering into that raffle, you can follow the link here. We also will ask at the end for session feedback and give some information on that. The feedback is important because it does help us to guide the conference moving forwards. So, right, Chris, if you'd like to go back to your first slide, which has got your email address on. Again, if people want to take note of Chris's email address, that's not this one, sorry. Well, I'll ask you to give your email address at the end, Chris, so that if people have questions at the end that they've not thought of, then they know how to get in touch with you. So, thanks everyone. I'm going to hand over to you now, Chris.
Okay, thanks so much. There's the first bit of feedback. I'll put my email address on slides in the future. Okay, good afternoon, everyone. My name's Chris Walker, and as Nathan said, I'm at IBM. I cover a variety of products, but one of the areas that I've been focused on in the past couple of years is looking at how we can support customers and technical people who are adopting or seeing their enterprise adopt tailored fit pricing. So moving away from the rolling 4-hour average, which has been very prevalent in the last 20 years. And we're seeing more and more people adopt tailored fit pricing, which is follows a more consumption-based model. In this session today, I'll be looking at a view of how we can help you identify the changes in behavior, assumptions, and how you look to manage workloads and leading through to optimizing workloads in this new consumption-based world. So moving forward, so a quick look on the agenda. This isn't a presentation about tailored fit pricing itself. I'm not here to advocate that you should adopt it, why it may be right or not right for your organization. That's something for you to evaluate and decide whether it fits with the goals of your company. I will start though with a brief level set just for the TFP for software model, just in case there's any assumptions that need to be clarified. And as I said, the focus is going to be on how adopting TFP impacts various stakeholders within the business, potential changes on those assumptions, the tooling that you're using, dealing with day to day, week to week. Operations really could be different on how you look to manage the performance and the resource and optimization strategies that you've done in the past. We'll focus on how in order to maximize the benefits of TFP, really making use of your performance data and performing analytics on this will really help you understand how the current workloads are managed, how future consumption is forecast, and then really exercises around how you can then optimize so that you're focused on the right things to do. Okay, so let's jump in. So I'll start with the quick recap on the tailored fit pricing for software model, and just I suppose a little caveat here. You may have heard that there is now a tailored fit pricing for hardware offering as well. I'm not going to focus on that so much today, but that was announced by IBM earlier this year, and there's a slightly different model, but it's about purchase capacity on your machines. So some of you may have seen this slide before, but really it's a quick review of how IBM Z software pricing has been provided or evolved up to today, and helps kind of explain why things have changed over time. Way back in the past, it was a very simple model. You bought a machine and your software licensing was tied to that. So it was, everything was full capacity. You buy a new machine and obviously the amount you pay for your software increases because it's directly tied to the capacity of the machine. There was a lot of assumptions tied into that. Obviously, a lot of the workloads were very batch oriented. So you're using, the assumption would be pretty much all the capacity of the machine at the time. And if you needed more capacity, you bought something bigger. Things started to change a little bit 20 years ago. So this was where the notion of sub-capacity pricing came in. So it was to say not charging to the full capacity of the machine, but looking at where the peaks were. And the reason for differences in how the usage of the machine was being done. There was still an assumption that at least 80% of the machine was being utilized. There was just, it was a very high utilization compared to other infrastructure, but there would be peaks within the week, or more likely within the month, that would show where the highest amount of use was, and software pricing was tied to that peak period. When that was introduced, and we know that the world of IT has changed considerably in the last 20 years. So the workload patterns that we see today are very, very different. Where the peaks are within your day or within your month are very different to how they were maybe 5-10 years ago. The predictability around that has changed because now workload is far more, or there's an increased amount of online transaction workloads that you see. So the mainframe is not isolated from it's being driven by mobile workloads, other off-platform workloads that could suddenly spike at some point and drive up the utilization of the mainframe. So what that really means is that people have had to invest in additional capacity, but it also means that sometimes the utilization is no longer always, over 80% all the time, but actually there are some very high peaks within the week or within the month, such that could drive up. And so in order to deal with that, you're obviously employing things such as soft capping to make sure that your costs remain in control. And as such, that is a model that's not really sustainable in the long term. Outside of the mainframe, we have a lot of consumption-based pricing. It's not really based around the peaks, and that was the focus of with tailored fit pricing, which would allow you to use the capability of the machines when it's needed, not be tied to a particular peak point, which is abnormal compared to the rest of your workloads, and would ultimately lead you to allow to architect towards the needs of the business and not just trying to control costs. So here's kind of an extreme example, but just sort of shows you the difference between how rolling for our average billing works versus tailored fit pricing. Each of these three examples here have the same 1,000 units of work. The one on the left is perhaps a little bit unrealistic. It's assuming that across the 24-hour period, you're using the same amount of work each hour. So it's nice evenly distribution. The work is the same each hour, and so the billing would be under a sub-capacity model would be tied to that 400 units of work peak. So that's pretty cheap. In the middle is probably what a lot of customers have been, workload patterns have been like for a number of years, where you have some peak periods throughout the day, but generally there are sort of high and low points across that. But the peak is at 800 MSUs, and obviously a 4-hour rolling average would be calculated based on that and the previous 3 hours. So that's where the billing point would be there. But as I was saying, the patterns are changing with the workloads. The amount of online transaction workloads that have increased, the predictability of where that peak would be has also altered. So on the far right is what we see in a lot of customer spaces now, where there will be a very high peak period. And obviously that if that is where the billing point is set, that is a considerable difference in the billing versus what you see in the middle, or certainly on the right. But they're all doing the same amount of work. It's just when during the day did this work get executed? So this is where IBM took a look at how the pricing model should work, and went to a is now offering a consumption-based model, which will say, okay, if you need to do 1,000 units of work and you have the hardware capacity to deal with it, you can run it on a consumption-based pricing, and you'll be charged for the consumption of work rather than when during the day or the week or the month the work actually took place. Okay, so that was just a quick level set of what we mean by tailored fit pricing, moving away from rolling for our average to a consumption-based model. So taking a sort of sidestep here, away from thinking about the billing, how does, if you're adopting tailored fit pricing with your organization, how does it really affect you on a day-to-day basis? And it's a good time to introduce 4 key user personas that we typically see affected by this. Some of you might be in these roles, or you know who they are within your organization, and they're really based on interviews that we've compiled over the past few years, who identify the challenges or concerns they had both with the old model and also, their concerns of adopting tailored fit or going forward. There may be other ones such as first line operations, application developers, lines of business owners as well. So we started by looking at what are their motivations and how they're challenged under the existing rolling 4-hour average, and what their needs are. So starting on the left, we've got our business leader, who isn't typically a technical person, but knows that the mainframe is really important to their business, even if she doesn't know why. The cost is very important to her, and she's an influencer when they're making buying decisions, or perhaps where to invest within the organization. So it's important to her to see accurate data about the true cost of the workloads. It's not unusual that we find people in that role who think that Z is expensive and maybe find difficult to find staff for, or are not clear on what the overall costs are. Second is our systems programmer, who specializes on Z. They often look at performance and capacity management and capacity planning capabilities as well. They know about the impact of the rolling 4-hour average, but they may not have an overall application end-to-end view. But what they're rewarded for today is really configuring the system to handle those peaks that we see, maybe implementing the capping that helps preventing workloads from running away at key times of the day and the month. And they work directly with operations staff, system SMEs, the capacity planner, to really react to issues. And then if we bring in our capacity planner, who's the third one here, he's looking at a long-term view. He's working with these multiple stakeholders to really influence management. And he's impacted by the rolling 4-hour average. He has to react when the peak workloads are maybe looking at making plans around how services might be reduced in some cases. He probably makes use of a number of tools that he does for administration, tuning, and planning. And in cases, he has some reporting tools, but also he's probably built up a big set of Excel spreadsheets that he's developed over the years to manage plans specifically for his environment. Or in a lot of cases, he's probably inherited this from someone else who's been working on this for a long time. And finally, we have a subsystem specialist who's probably looking after, KICS, DB2, IMS, and has a deep technical knowledge in that area. They are often frustrated with the current, or with the status quo, because they are responsible for maintaining SLAs on these systems and applying ongoing maintenance to their system. And they can really be impacted by the capping rules that's placed on them from above, and that results in suboptimal performance. So what we see is that a lot of the stakeholders today are focused on optimizing for cost, and that means that that introducing capping, and that can lead to challenges, because when you look at the capping and how it manages the rolling 4-hour average, it didn't come for free. It keeps things down on the bill potentially, but you had to pay in terms of effort to manage it. And that may also impact on CPU delays, response times, problems, maybe even SLA misses, because important work is being displaced by other work, and we're not able to take advantage of the full capacity of the machine. And so people are being rewarded for really trying to optimize for the rolling 4-hour average, which is billing, rather than optimizing performance and throughput for the overall benefit of the business. So this is where we hope that tailored fit pricing will address this. And so the way we look at this is that there are new focus areas that you need to start thinking about. Our business leader, of course, is still focused on the cost and business value, but with an operation under consumption-based pricing, she has a plan to really she can understand and commit or track against. She can look at how much MSUs that can be consumed over the lifetime of the TFP contract. And she needs to understand how she's doing at tracking against that plan. She can know, am I on track for that number of years that I've committed to? Am I going over, under? Have I got room for more workloads? And therefore the mainframe is an attractive place to place new work. Jumping to our subsystem specialist on the far right, who was previously technically impacted, he can really help here by looking to optimize, reduce the MSU consumption on existing workloads, and he can have a lot of space to actually look at this. He can look at the 24/7 period, because every MSU within a TFP contract is of equal value. He doesn't have to focus just on that peak 4-hour period each month, and really can help reduce MSUs of every minute of every day, look at tasks that are being done outside of the peak that you can focus on. Our systems programmers and capacity planners in the middle can really be focused on every hour of the month too. And they're really empowered to maximize utilization of system resources without the concern for the peaking or the capping. They can use the resources where they're needed. They look at a longer term trend in terms of, and look across all workloads, so that you can take advantage of the hardware resources that have been paid for already without constraining it. So really everyone's focus has changed slightly since the capping is not in place. The peak is not a concern. There are many more hours in the month that they can look to optimize, and we'll take a look at this in a bit more detail to really help reduce costs and make best use of the move to TFP. So here's a real example of what happens when someone moves, and this is data that a customer did share with us on how their workload models has changed. Under the previous model on the left, you can really see the impact of the soft cap throughout the day. Obviously, you can see that there's a large amount of online workload that takes place during the day, and then the batch workloads are processed predominantly overnight, starting, it looks around about 8 o'clock, and runs through to sort of 5 in the morning. And you really couldn't run it any other time of the day because of the demands of the online work. And the only spare capacity is really within the overnight period. The important point to remember here is that the work required to be done hasn't changed. It's still going to take a certain amount of processing for that batch workload to complete, but the scheduling of the work is fitted around the cap, and the cap is really only in place to control the costs. So the same workload distribution of the TFP on the right has quite a different profile here. The online processing is the same. However, there's flexibility to make use of the full purchase capacity of the machine. You can now see a lot of the batch workload starting early in the day, and it actually completes much earlier too. The cost of processing this doesn't change, but you can really see there's some benefits by having some flexibility in the system. If there's maintenance, or maybe even if jobs need to be rerun in case of problems, there's some excess capacity there that can be used to take on, or you can look to take on additional workloads as well. From a capacity management, capacity planner part of view, you could almost demonstrate back to the business that you're making full use of that purchase capacity, and also you're getting away from micromanaging the schedule as well. So as we go into this consumption model, enterprise consumption world, what do we need to start really thinking about when we're managing the system? Everybody wants to focus on optimizing the MSU consumptions for the existing tasks. There's still things that need to be done every hour, every day of every month, and you might start to sort of think, well, what can I do to optimize or reduce the MSUs for those tasks? We also want to understand what tasks have been done outside of the peak, which was really not a focus previously, but perhaps they could be eliminated, reduced. Maybe you can identify some jobs that have been running that are unnecessary, that really aren't adding value to the business, but in the past you never focused on that because it didn't contribute to the monthly peak. It was something that ran at 2 a.m. Didn't really impact your overall software costs. It ran in what we might say the free white space. The critical thing with tailored fit pricing and any kind of consumption-based model is that regardless of what time of the day or the week or the month it runs, it's that MSU is of equal value. So a real focus on eliminating or reducing those redundant or unnecessary tasks, anything that's really not adding that business value, gives you and when you do both of those things, you begin to make room in your existing environment to either increase existing application workings and grow workloads, stay within the baseline levels of your TFP contract, and what you've done is created additional value to make room for new work, grow workloads without incurring any further costs. So in theory, this is a good set of tasks that focus on. So the next part, I'm just going to start to look at how we can use analytics and other techniques to address some of these needs here. And when we start to do this, I look at this as a two-phased strategy. There's a couple of things that you need to get a view on in order to make the best use of this. The first phase is really to understand what your workloads are today. You've got a good handle on what they're doing and have a view of how things are changing going forward. So understanding the existing performance of your system and all of the workloads across every hour, every day of each week will really help you understand and have visibility on what you're doing. Probably under the existing rolling 4-hour average, there was a very focused look at understanding when the peaks and knowing what workloads were likely to contribute to them, and aligning things and excluding things that were never going to be involved in that, and never actually taking a look at what those are. So under this new model, you have these workloads running in what are known as enterprise containers, understanding the performance across the entire month and not waiting till the end of the month to have a report to show you what you've consumed over that period. So from a management perspective, I think there's a real need to have an on-load day basis. From that point, you start to once you know what's being consumed and the changes that are occurring there, you can start to make forecasts on what that future consumption may be based on the trends and maybe some knowledge about how your business direction may be going in the future. This can then lead you into the second part, which is now when you start to think about the optimization and looking for those opportunities. And this can be improving on existing redundant tasks, as previously mentioned. And we're going to look at this in 3 parts. Firstly, we'll look at application optimization, and then subsystem, and then finally runtime optimization. And these approaches really can help you look at your existing workloads, potentially reduce the number of MSUs, and also improve performance as well of the system. So a tool I'm just going to use in the next section is called IBM Z Performance and Capacity Analytics. There are other tools that you use to track performance. This is a solution that we have that addresses some of those challenges mentioned previously. It's an SMF processor. It curates the data and builds up a near real-time analysis of your performance and resource consumption. And when I talk about ICPCA, I focus on 3 areas. The first is performance analysis. So looking and measuring, checking the levels of performance in terms of productivity, cost reduction, really taking the data you have about your environment and the workloads, draw out important insights, changes in performance, and really support subject matter experts in their analysis. From there, it can also help you with capacity forecasting to help you ensure that that capacity of the infrastructure is able to deliver service level targets in a cost-effective manner. So not just using data for reactive analysis, but also proactive tasks to help the business make those correct decisions, and also tie it into cost management so that you can actually show who's using what and leverage this for potential showback or chargeback capabilities. So I'm going to use a number of the reports that the PCA provides that focus on TFP to help guide us through some of the exercises that I'm going to, and scenarios that I'm going to show next. So if we start with the basics of TFP, the first thing you really want to think about is what are you consuming today? At a basic level, you could use an SCRT report to see your month-to-month consumption, but likelihood is that's just going to show you the consumption based on the container, and the container is what is defined within your TFP contract that says, okay, this is where these particular systems are grouped into this container, and this container has a certain amount of MSUs that you can consume as a baseline for the year. The chances are you probably want to have a more detailed view. You want to see, firstly, how are we tracking at a more granular level, at maybe a weekly level, to see what's happening, if anything changes from week to week. And so as the weeks and months pass, obviously you're consuming more of your baseline. You want to see how you're tracking against that. How far through of the year are we through? How much through of our allocation are we through on the baseline? And obviously, depending on what industry you're in, probably got peak periods throughout the year and quieter periods as well. So you wouldn't expect a complete linear level of consumption as you go through, but obviously you'd like to know when you're going through your peak periods how much that's consuming, and if you're obviously going through a quiet period, make sure that you are tracking at a lower level as the business would expect. So here I'm showing a couple of containers that have been defined, and it's fairly sort of self-explanatory. As you go through this, you can see the light blue is showing you how much of your baseline has been consumed. It's kind of going up incrementally throughout the year, and how much of the baseline is remaining as we progress through. And you can look at that at a particular level and progress. But then actually what's actually going on inside the container is incredibly important as well. So what you want to do is to start to drill down and take a look at what's happening in there. So here, as an example, we're starting to drill down, and we're going to look at one container in more detail in terms of what was consumed each week as we go through there. And then obviously within that, you've got the different workloads and the different LPARs that have been allocated to the container. And so actually having a view of what's going on inside there is really important. So we're now looking at, within one particular container, how much MSUs were consumed on each particular LPAR. Maybe one is obviously running a lot more work. Maybe you've got some kind of balancing issue that you'd like to look at. But here, each color represents a different LPAR, and how much each of those LPARs is contributing to the overall container consumption for that particular month in this case. But you could go to a more granular level, such as a daily or weekly level, to see what's happening there. And then obviously within the LPAR, you've got service classes and workloads running. So drilling down further to actually see who's consuming what within that period is very important. You might want to be able to group those particular workers together in another form to show which maybe a department within the organization or other groupings, in order to understand from a cost perspective who is actually the net contributor in terms of MSUs, and focus on that as you go through. So that's a level of visibility that you need to have to start off with. You're now not just looking at, okay, what's running within a peak period. You want to look at particular times within the week or the month to actually understand if something's happening. And this may have got you to start to think about some of the challenges you might want to face around analysis. Peaks are still important within a TFP environment, but really what you want to be thinking about is the averages. Obviously, if you're seeing your peaks get higher and higher over a period of time, that's obviously reflecting some kind of workload change there. But maybe that peak is just a blip. Maybe it was just because of a particular period of business, some business driver that's caused that peak on a one-off occasion, whereas in the past that would have been a problem. It may just have been a blip, as I say, that will not repeat itself. What you really want to be focusing on with TFP is what's the averages that's changing here. Are we consuming 3% more than we were last month or last week? Is that a consistent growth, or is that something that is going to drop down again in the future? Understanding if that is a problem that needs to be addressed, a change in behavior, or some kind of trend that's occurring, and was that expected? So the peak is growing, and if you look at this particular graph, we can see that the light blue is what the peak was shown on each week, and that's gone up consistently over time. However, the average number of MSUs consumed has been relatively flat. And what we can kind of infer from this particular data is that actually there may be more spiky workloads occurring that have driven up the peak. But overall, we're not consuming that much more than we were in the past, because the average is at a low level. There's a slight little increase, but nothing towards. So that's not reflecting a big challenge in terms of overall consumption. But we might want to look at why that's occurring. So we would drill down a little bit further and take a look at that. So as assumptions around the behavior you're looking for changes, you may also want to look at changes in how you're doing alert set within tools to ensure that if you're looking for this behavior, that they're triggered for the right changes in expected performance. If you're tied very much into a capping model, your alerts may be, you may see a number of false positive alerts, and you want to look at points in behavior that would actually preempt potential longer term issues instead. So in this example report, we've built up a expected model of performance across every hour of every week by the green line across there. The blue bars represent the actual observed performance on those days. And so this is helping us to understand whether we are tracking with a normal system behavior, or whether there is something there that we want to perhaps investigate. And we can produce a threshold or alert that would tell us if there's something that's slightly different. So obviously understanding what's the normal system behavior at different times of the week is important. something at 9 a.m. on a Monday is very different to 1 p.m. that afternoon, or even 9 a.m. on a Thursday morning. So using building up a knowledge of what's the expected performance will allow you to be able to identify when the unusual behavior is occurring, and that may be because of a trend that's in there. And the two little red circles will obviously are highlighting where we've seen observed performance that's greater than is typical for that expected hour period of the week. Maybe it's a blip, but if they're starting to see a lot of changes that are deviating from the expected, that could be investigated as actually a bigger trend. And so it's not just about being reflective behavior. Forecasting is very critical to how we actually are doing as well against expectations. So taking our MSU baseline for the year, we want to make sure that the year we are in line with what the business expects. And that may be that you're growing. If the business is growing, then you expect to consume more MSUs than you maybe have been allocated in the baseline. You've gone into growth MSUs, which are competitively charged to encourage that growth. If you're not, then you want to be able to take proactive action to ensure that the amount of overall consumption on the system is in line with what you need. So do some kind of forecast on the MSU consumption is very important. And in this example here, the horizontal line that you can see is our baseline for the year. And we've taken this forecast probably 2/3 of the way through the year. We've got a trend that is showing us where we're tracking across the year. And the forecast is applied and it's pointing out that just before the end of the year, we're going to cross over the baseline and into growth. And as I say, that could be seen as a good thing. The business has grown this year. We've had expected better, we've maybe brought some more workloads on, but we've crossed that line. We're going to move into growth MSUs. With this forecast, you're able to make that estimate, and you also make an estimate really about what that delta is going to be in terms of what the additional cost would be on the growth MSUs. So that's not a surprise at the end of the year that there may be an additional processing bill that needs to be dealt with. Alternatively, let's say that we think that actually this is a little bit higher than we expected, and we need to look at our overall systems to do this. That will give us enough visibility up front to turn around and say, okay, what can we do to reduce our number of MSUs in the remaining months of the year or going forward into next year so that we can keep things in line. Starting to drill down and understand which of the workloads that have grown in terms of percentages. Some of the optimization strategies that I'll talk about shortly will also feature into that. The important thing, the forecasting allows you to make a decision based on business terms and really make an informed decision on what to do early enough within the year, so that you're not getting to December and realizing that your consumption levels are out of line with what the business is thinking. So, for example, tying this back, if there was a demand from the business to say, okay, we need to drive a new sales event, can we really estimate the impact on our workloads? Well, having that visibility, understanding of what workloads are running, what are consuming things, where the actually estimate the growth on there, and also because we're looking at a consumption-based model, we can really have a much more transparent view of how we can incorporate those costs and tie that back in, understand the impact on the workloads. We're not kind of getting a bit confused because we're thinking about the rolling for our average and whether these sales events are going to be can be accommodated by running into our peak period or running into a capping level that means that down, or we have. And just to really, emphasize this point again, and what we're going to look at now is how we optimize the resources within the environment. And this simple graph here is really showing you, in the past, all of the focus on optimizing and all of the focus on where the skilled staff will be focused on is really that 4-hour peak period, understanding they're excluding anything not required, making sure that there are no surprises, and balancing around that. Now that with every MSU is of equal value, whether it's running at 9 a.m., 2 a.m., Saturday or Monday, the focus is just as much to look at what's going on outside the peak period as well, just to ensure that you're making best use of the resources that you have. So let's look at beyond just managing and start to think about the optimization of the workloads. As I said, we've subdivided them into 3 sections: application, optimization, subsystems, and runtimes. So if we think about where we've done the analysis of the workloads that have indicated MSU growth within existing the environment applications, how do we really go about taking action to drive efficiencies across those? This is really tied into the performance of the system as much as cost implications. If you've got inefficiently executing applications, that can cumulatively also impact SLAs as much as MSU consumption. And so really the discipline of application optimization is looking at that poor performance flow, identifying bottlenecks in environments, really make improvements, and that will benefit both cost and performance within these areas. And that performance analysis of your applications, those program flow issues, maybe taking advantage of things such as in-memory caching to shorten code paths as well. When we talk about subsystem optimization, we're looking at the actual subsystems themselves and how we manage them. So a lot of the traditional subsystems on z/OS like DB2, IMS, and KICS, we perform a lot of tasks on a regular basis to keep those subsystems running smoothly, efficiently, and most of those admin tasks are done outside of the rolling 4-hour average, which really means that those maintenance and management tasks have been traditionally done in off-peak hours, and therefore there hasn't been a lot of focus on the MSU consumption of these tasks. It didn't really impact the MLC cost of those software. Again, to reiterate the point, every MSU counts under TFP, so looking at those tasks outside of the peak now counts. If we look at each of these tasks and understand what we can optimize, then we can reduce the MSU overall there. We can look at which tools are being used and look at ones that can run with fewer MSUs than the basic utilities that come with this. There may be tooling that could be invested in that help optimize things. We can look at the way that perhaps we're doing database backups to reduce redundancy. We maybe don't just want to reduce the number of backups, but we can also look at tools that might be able to do the backups differently with a few. Using those tools can also have a side benefit of reducing the skills requirements and help you implement best practices as well. So there's a lot of things that can really be focused on there on that part. But secondly, we also want to use the tools that give you the ability to collect data as the subsystem is running and understand if those management tasks, such as database reorgs, actually add value or do they not. You might be doing a database reorg every week or every month for the last 10 or 20 years, and that's just the way you've always done it. But because no one's focused on it, because it ran on a weekend and way outside the peak period, that may not be the most optimal way of doing things in the future. Look, you need to understand which tasks are adding value and are not. And potentially you can use tools to help you automate some of these processes, determine which tasks do add their value and which ones can be reduced. And then the final area of optimization that we can focus on is around runtime optimization. So you'll have heard from us, we have to move away from the mindset of optimizing in the peak period and look at the whole week instead of the 4-hour part. And there may be a lot of applications that have never run. These may be applications that you've not thought about in terms of improving, optimizing, not just refactoring, but just even thinking about when were they last recompiled? Is there a COBOL application that was last recompiled 6 years ago? There's probably some low-hanging fruit in terms of optimizing some of these applications and also lower the overall MSU consumption levels. We'll mention the role of zips as well here. So they've obviously been available for a number of years to reduce the impact on MLC costs, but in reality, the real benefit was only seen within the peak period. If you had some zip eligible work that ran on general processes outside of the peak, from a cost perspective, that impact was fairly negligible. Under TFP, you want to maximize the use of the zips that you have at all times, because any workload that runs on a zip doesn't contribute to consumption. So as a result, really having a good view of when zip eligible work is running, ensuring you have the right amount of capacity at that point in time, really would be a valuable exercise to complete as well. And it will help you improve the utilization of the zips, and also identify whether there is additional benefit from investing in further zip capacity as well in the long term. So I mentioned the sort of 3 areas of optimization just before, and I want to just go into with them. Just in all cases, you want to be able to really validate the changes that have been successful. So there's a real process of detecting, isolating an area of focus, make a decision around what you want to do to fix, and validate that change so that you've done this. In all cases, optimization is often an ongoing process. So there'll be incremental improvements rather than one big one-off change. Although, if there is a lot of, as you first move to TFP, there's probably a lot of a big level of improvement quite early on. So in this example of application optimization, I'm looking at some DB2 workloads, and it really starts with our systems programmer who's looking at top consuming MSUs or looking at overall MSU consumption across a whole level of workloads using something like performance and capacity analytics. And let's say he sees some interesting information that he wants to, he sees some particularly high consuming applications and sends it over to our enterprise architect. They may want to look at something like the top consuming DB2 workloads from the applications from the existing report. Working with a subsystem specialist, he could maybe identify some candidates of workloads that are consuming a high number of MSUs and maybe could be improved by using some application tuning tools. Once they really have a chance to diagnose the amount of CPU or cost savings under consideration, they can pass that along to the middleware programmer who's could get an appropriate action using some tooling, perhaps using a in-memory optimization tool that would shorten code paths, shorten the amount of processing that actually takes place on DB2 as well. And then once those changes are done, it can then, to complete the circle, we then continually look at the MSU reports to see who's consuming what and validate that to see that the effective change has been made and improvements that have been done. And if there's further optimization, look elsewhere. Let's take a look at the subsystem optimization. I previously mentioned database reorgs. That's an obvious one for a lot of customers, whether you have IMS or DB2. You first really need to identify the database reorg jobs that run on a regular basis, And our subsystem specialist would be the person who would look at that. And remember that these are jobs that may have been defined many years or even decades ago and have just always been the way that we do things. Once those particular tasks have been identified, we can cross-reference that against the MSU reports that we performance and capacity analytics to understand and report on the MSU consumption of those jobs. And then really start to think about changes to those jobs to collect information about the database, schedule the jobs to run, but change them so that they can be conditional or conditional reorg, so that you have a policy defined based on examples. So you can determine if or when to run the reorg rather than always running it. The policies may define thresholds where a reorg will add value in order to justify the MSU consumption of running it. There are many tools within the portfolio that could do this. For example, with IMS, you could use IMS database reorganization expert that would identify when a reorg is justified and warranted. Now you just made some very simple changes. Instead of running the reorg every time it is scheduled, it will do a conditional reorg, only run when it adds value, and that will then overall drive down the number of MSUs that are being performed, and we can validate how many MSUs are being saved. And those MSUs are really available now to do other tasks. So you can schedule more other things that are of high value rather than just consuming on maintenance tasks that weren't adding value in the past. And finally, let's look at one about runtime examples. So I mentioned this earlier, but really optimizing existing workloads. So we may look at a lot of the applications that are running outside the peak, and we may have noticed that there are a set of COBOL applications that are particularly heavy consuming MSUs. That can be pushed to the application development team and the architects there to review what these applications are doing, and maybe think about devising a plan to modernize some of these applications. Maybe some are irrelevant, and as we see in the past, don't add value, so they could be adjusted, refactored, or even taken offline. If they're an application that's really under current development, we could recompile these using the latest level of COBOL. Maybe in the past it was, if you've got it, recompile it with COBOL 6. There are additional instruction optimizations, and it can take advantage of the latest hardware that will actually, without any real refactoring, has been able to drive down the cost and improve performance of those applications. If there is an older application that's maybe in maintenance mode, or maybe knowledge about how the application works at a code level, it has been lost over available. Automatic binary optimizer, which will be able to also gain some benefits from running on the latest hardware updates. So this really helps that we can then make some very important and very easy changes in a lot of cases in order to optimize our workloads. So let's finish up here. So as you've heard me say many times over the past 55 minutes or so, with tailored fit pricing, really MSU counts and that change in how you manage and optimize across the mainframe. Stop focusing on activities that run within the 4-hour peak, which you've maybe looked at for decades, and focus on activities during all hours of the month. And there's really likely many things that you've been ignoring from an optimization perspective that are really prime targets now, and a lot of low-hanging fruit that could be done. You probably spend a lot of your time optimizing so with that in mind, there are tools available that can help you understand which tasks are adding value, which are not, eliminating those tasks that are not, optimize the MSU for the tasks that really do need to be done, and then continually analyze it so you're not just looking at what's being done today, but continually evaluate, report on consumption, forecast where you're going, and help track the consumption levels on the mainframe alongside what the business goals are. And ultimately that will improve both cost and performance of your application. So with that, I'll upload the slides after this session, and there's some additional information about some of the tooling that I've spoken about today. Please do feel free to reach out to me if you've got any follow-on questions, if you want demonstrations, if you want any other discussion on this. I'm very happy to have a follow-on discussion on that. And please do also provide on this session and others across the fortnight. I do appreciate any feedback that you have on the session today. And I think that's all I have to cover. So if there are any questions in the last few minutes, please let me know.
Thank you, Chris. Yeah, thank you for that presentation. It was very interesting. As Chris said, if anyone has any questions, you can submit them into the chat at the moment. Or Chris, would you be able to share what your email address is if people want to contact you directly?
I will. I'm going to fire this up on here so everyone can see it. So I'll put it in the uploaded version as well. So
excellent. So crwalker@us.ibm.com. Great. So we'll just give people a couple moments just to submit feedback by chat. Sometimes it can take a minute to type and a minute for it to arrive, depending how our connections are. So we'll just give it a moment. So whilst we are waiting, as Chris said, your feedback on this session is appreciated. You can find that on here on the GSC website by contacting Chris directly. And as Chris said, you can get a copy of the presentation for your own perusal following this session. We ask that you attend all our sessions next week. This is the last one on this stream for the week, but there will be more next week, and hopefully we will see you all there. We've not had any questions through so far, Chris, so I think we'll leave it there. So yeah, we'll leave it there. Thank you, everyone. I appreciate your time and hope to see you all on sessions next week.
Okay.
Cheers. Bye, everyone.
Thanks, Nathan. Thank you, everyone.
Thank you, Chris. Bye.